Anyways, this is just the specifics of the actual hardware that we have implemented and the type of services that we have. I'll give a couple more specifics as to the hardware later on. I don't want to get really buried with bits and bytes right now. This is more going to be a talk about data patterns. So the story starts about 6 years ago when we did a reorganization. And I don't mean a organizational one, but I mean where we actually took a look at our hardware infrastructure and we redesigned everything to be focused more around data. Before this time, we were what I would call a very typical HPC shop. We had our clusters, we had storage attached to them, and everything just sort of was in their own little silo. About 5, 6 years ago, I gave a talk at SC where we discussed that we put everything onto a parallel file system, including user integration onto the system itself, and have been serving out our users with that. At the time, you can see we had a usable space of about 2.5 petabytes. I need to be a little more clear about when I'm giving specifics like this. This is active data. We don't count archive data or stored data to any of our totals because, quite frankly, that gets ridiculous. We'll be dealing in the hundreds of petabytes, and that's just not realistic. So whenever you see data being quoted here, it's actually bits on the wire and stuff that is moving. So this was actually very, very good, and we were in a fine space at that point. We had our one main cluster, Pegasus, which was about 10,000 Intel cores, had about 150 terabytes of scratch space provided by DDN. You know, it was just a very nice thing. We did, as I said, do something a little different in that we have interactivity based right on the cluster itself. We don't ask people to go to their laptops and then actually transfer data across. We support graphical desktops directly to the supercomputer right now for them. To give you an idea of some of the cases that we work with, we have a lot of hurricane prediction, as you could figure in Miami. That's something that's very important to us. Climate change, yeah, that's another no-brainer. It's kind of important to us too. I live on Miami Beach. I don't know if anyone's heard about the king tides that have been out there reasonably, but let's put it this way. I needed a kayak to get to the office the other day, not a car. It was bad. And then finally, the other traditional thing that we support is computational fluid dynamics in the engineering group. As you look through here, you're going to see some I/O patterns that we've seen put in here. I'm going to talk a little bit later on about how we actually achieved those I/O patterns, how we figured out what they were and what they actually mean to us. But you can see through here, these are not particularly I/O challenging for us. These are broad streaming reads, writes. Codes tend to be very super serial and have very little I/O, or it just didn't matter to us. Until, of course, we get to what is my original field, which is the life sciences and biology. I actually come from Merck originally, Merck Research Labs, and then I was at the Scripps Research Institute for a number of years as well. So I come from the life science industry. At the time, we had a number of sequencers that were going to there, mostly HiSeqs at this point. We had about 8 or 10 of them, a bunch of 3D microscopes, not a tremendous lot of old cruft. Okay, anyone ever sees a dropper or 454, cry. Pretend you don't have to do that. The nice thing is these are all network attached instruments for the most part. We didn't have to worry about moving data back and forth. They were all designed to actually be put on the network and feed everything to our centralized array at this point. And that worked very, very well as well. And you can see in here the type of I/O that we had was also highly predictable. I could tell when somebody was running a cell line. It was that obvious on the storage. Our users as well were very, very predictable. They were true professionals, and in an academic setting, that's sometimes hard to say, but these people truly were. We had the Hussman Institute for Human Genomics, Sylvester Cancer Center, Baskin-Palmer Eye Institute, and these were professional bioinformatics groups. Okay? What that meant was that their workflow was highly repeatable. We knew what they were going to do when they were coming onto the systems. So we were in a good shape whenever we had to have problems running on the system. And the other thing we could find out is that these users were very highly communicative. They talked to us. We knew when there were things going on, when they had a big challenge that was coming on, they would talk to us. And never underestimate how important that is when you're running a high-performance computing core. Well, about 4 years ago, everything in my life changed, as it always does. The University of Miami decided that we were not only going to be a university, we were going to be a hospital as well. So we actually went out and we bought University of Miami Hospital, formerly Mount Sinai, Cedars-Sinai Hospital. And all of a sudden, we had a tremendous amount of ancillary data, what we viewed as ancillary data. Now, we've been dealing with petabytes coming from the sequencers beforehand, so when they came to us and said, well, we've got about 10 terabytes of data on here, we just sort of went, yeah, sure, whatever. We do 10 terabytes in our sleep. That's really not a problem to us. Boy, was I wrong, folks. The problem that we realized was that the utilization of this data was nowhere close to anything we had ever seen before in our lifetimes. Okay? We couldn't put this stuff into databases because the way that we were trying to look it up, indexing took forever. We couldn't put them in flat files because then we would have files all over the bloody place and we couldn't account for anything. We had a real problem at this point. And the biggest thing I had to deal with at that point was the unstructured data. Sure, we've all done the trick. You take a blob in a database, you assign an image to it, you can look it up, no problem. But now all of a sudden, when I'm dealing with health records that are changing rapidly, I can't play that game anymore. So we were really in a tough area. So we all of a sudden come there, and my boss comes to me and says one day, "How we doing?" I look at him and I say, "Well, I think we're doing okay. Here are our average wait times. Our utilization is pretty good. You know, we've had reasonable change in users, but you know, we can't really tell you anything about the individual user. I can tell you what the system is doing, but I can't tell you what individual users are doing anymore." Reason why was because we had everything put into the traditional methodology of analysis. We were using an LSF job database, a job log, which worked very well, don't get me wrong. Okay? We had our file system information and our hardware logs. All in all, we could give reasonable answers, but nothing particularly important with it. But as we started getting this data in, this health data, I switched slides too soon, my apologies. But as we started getting this data in, we had another problem. The rate of change of it was so dramatic that we couldn't keep up, period. There was just no way. Now, it doesn't surprise when I hear a lot of things like terabytes per day being thrown around. I hear streaming data doesn't scare me anymore. How does 1 million transactions an hour sound to you guys? That scared the hell out of me, okay? All of a sudden, I literally could not keep up. And folks, I have a pretty hefty infrastructure, okay? Fortunately, I'm an IoT researcher on the side, and my research group came to me and said, "Hey, you know, we've been dealing with this type of streaming data for years that you've been giving us. Why don't you just take a look at what we're doing?" I was a little embarrassed because this is my own research lab telling me this. But sure enough, they went through and they said, what we have is a big data solution. What we can actually do is take these health records, put them in there, use Flume to transfer all the data, put everything into our big data system. We're able to query everything very, very quickly. I mean, heck, we've been doing it with sensors for years, as I said. This shouldn't be a problem, and we were all okay. And sure enough, we started using a big data system for our health records and everything. Everything was going very, very well. We were very, very fortunate. Well, as users are wont to be, they tend not to use system utilities. They want to use user tools, right? How many people out here support MATLAB, RStudio, things like that in their environment? Anybody out there? I can't be the only one. Okay, we all do, right? Well, this was a big thing for us because on the big data system, we could put MATLAB on the front end. We could put RStudio, Pentaho for ETL. This wasn't really a problem for us. But time marches on. All of a sudden, it's 2 years after that point, and now all of a sudden, I've got 20 HiSeqs sitting there. We move in 10 new microscopes, and all of a sudden I have to deal with image data as well. Now I've got another problem, as you can imagine. S3 compatible storage. How many people out here are using S3 compatible storage? Is anyone else? Yeah, okay. Have you found a good solution for it up there? Because I'm still breaking my head against it, but we'll talk later. What we really noticed more and more was that as we were moving along, our data access was no longer streaming. We were seeing far more random data access, okay? After a while, we tried to figure out why this was, and we started talking to our users and what have you, and we found out that, well, all of a sudden, we had a lot more interesting information to our users. We now had health records that they could tie back to the actual research that they were doing. Well, this means that all of a sudden, we had to make the access to the data easier, and we did, and that was good. Finally, we did. We put all these interfaces that we see up here attached to our system as well. And our user base increased dramatically. We went from about, 1,200 users to about 5,000 users in the period of under a year. It's a lot for an academic institution to try to deal with. And then we started seeing other users as well, not just our traditional scientists and STEM people. We started seeing business people, lawyers, believe it or not. Look, what legal people want to do with high-performance computing, I don't know, but they're doing a lot of it right now. And we were seeing a tremendous amount of collaborative work. So we had to be able to share our data across everywhere. Guess what broke? We kept trying to feed everything into the big data system, and it choked on us. We couldn't do it anymore. It wasn't the size of the data. We could put more disks and more nodes into the big data system. That wasn't really the problem. We couldn't get the data on and off efficiently anymore. It's a problem we see with the instruments all the time, right? But we could literally not get the data in and out. So this was no longer good for us because we're still receiving all of these records at an unbelievable rate, and we don't know what to do. Luckily, we talked to our friends at both IBM and DDM, and they were able to help us with GPFS on that point. Turns out there's a big data connector within GPFS. So instead, we actually disassembled our big data system. We actually managed to migrate everything over to our main cluster, and we were now able, by using the analysis stack that we have, the LSF Yarn metascheduling, any user can now run on Pegasus itself and get to all the data that they need to, without any of the roadblocks that we see beforehand. And this was actually a fairly transparent change for us. Now, what that happened was all of a sudden, we grew a lot. So I had to go and say, we need more gear, as we always do, right? So I go to my boss and I say, I need more stuff. And some of you know my boss, and he turns to me and said, that's nice, prove it. Well, I had a problem, folks. All of a sudden, all the hundreds of thousands of little jobs were overwhelming all of our tools. We could no longer keep up with the databases that we had, so we weren't able to do any decent reporting out of them. Not only that, but we had a ton more system information coming in as well. We were integrating from all the different instruments, all the different file systems, everything into one place. And the information was just changing too rapidly. And as you can see at the bottom, all of those lovely data patterns were becoming lost in the noise. We could no longer tell what was going on, okay? Which is bad for us because predictability is important in this type of system. We need to know what's going on so we can make sure that the system runs appropriately. Well, I went to my boss and I said, well, here's my problem. I don't know what to do. I can't give you decent metrics on anything. And my boss turned to me, and as Anthony sitting up there can attest to, he said, time to eat your own dog food. Okay? You're setting up all these wonderful systems for everybody else. Why aren't you doing it? Well, I felt a little stupid after that, and I went back to my wonderful research lab and I said, guys, I got a new challenge for you. And they looked at me and said, we solved this years ago. I'm like, why didn't you tell me that? Anyways. So what we did is we actually set up a Spark streaming server for all of our incoming information. And we were able to feed this real time to our Pegasus system, our high-performance computing system, and all of a sudden, we could now get a handle on what was going on to the system. The patterns are there. They're not hard to find with it. So we use these regular tools that we use, such as MATLAB. I myself got onto RStudio with it, and we were able to actually find out what was going on. And we found these three major trends that were there. We found significant data trends, user trends, and actually organizational trends, which was the most interesting thing to me about all of this. Let's talk about some of the more obvious ones right now. Data trends. Over the last 3 years of analysis in our areas, we've discovered that for interactive utilization, I can't speak specifically to stream, but for interactive utilization, metadata is king. If you can solve your metadata latency issues, your users will love you because they're going to feel like they're sitting at a desktop. Okay? 95% of all queries to read for data, in our experience, were metadata. Okay? We were able to turn back, all of a sudden people are typing LS, DIR, you name it, whatever they were able to do, it was coming back significantly faster for them. We did this by putting in, I won't steal my own thunder, but by once again working with DDM, we solved this problem. Okay? User experience is all random I/O. Okay? We're not seeing blocks being transferred. We're not seeing streaming. The number of cache hits that you see, translation look-aside buffer hits that you see, misses that you see are staggering when you have actual users who are, well, let us put it this way, who don't necessarily know what they're doing on the system. So they try a lot of different things, they experiment, and this turns out to be a lot of random I/O that we see on there. And then finally, the last thing I saw was that, for our experience at least, and I encourage you to look at this in your own organization, IOPS turned out to be a far more important metric than bandwidth. Okay? Everyone always talks how they can turn 56 gigabits a second over InfiniBand, 100 gigabits with EDR, what have you. If you can't turn 250,000 IOPS out of your storage pool, you're going to be dead in the water. I don't care how much bandwidth you have. Please start looking at alternate metrics. It will save your life. Growth trends. Here was something that really surprised me. I had always thought that our growth in Scratch and everything was significant and that we always needed to have more Scratch space. No. I actually found out that mid-IOPS, where people are just having, I don't know, 500 to 600 IOPS per session, per user session, was where the most of the growth was at this point. This could be satisfied with pretty traditional hardware, by the way. You don't have to get exotic with it. For growth, and then finally, significant growth, mid-IOPS, as I said, and then long-term storage. There's no surprise here. This is an obvious statement. The growth of long-term storage is exponential. We know this. Okay. Most importantly, what I was able to show to my management, we actually had numbers to back it up at this time. We could show growth rates month over month for specific use cases, which was great for us. User trends. Well, user trends were a little more interesting for us. Because while we could always tell when was the last time you logged on the system, I could tell what program you ran or what have you, I didn't really know what you were doing. Just knowing that you're running script ABC is not as informative as you might think. Okay? But we were able to take this data, and because it was already on our supercomputer, we were able to apply a machine learning framework to a lot of this, to our data, to our user information. Okay? We found out that in the end, most users are pretty predictable. You're going to do pretty much the same thing when you log on to a system. Okay? May seem somewhat obvious, but we actually have mathematical evidence now, finally. And we can actually anticipate when you're going to do a large data transfer as a user. Growth patterns, one of the most interesting things we did is we no longer look at users by which organizational group they belong to. That's not relevant to us anymore. What's relevant to me is how do you functionally use my system? Okay? And this is where we were actually able to classify users using the machine learning framework. Once we were actually able to find these classifications of users based on I/O patterns, all of a sudden we managed to see trends within those I/O patterns and within those functional users. As I mentioned, our interactive use grew significantly. Order of magnitude, it grew in a period of a year. Okay? Our casual use, people who would log on once every couple of weeks, every 2 weeks or so, was actually a lot higher than I thought it was. Okay? And our expected growth, our instruments, what have you, those were predictable. When an instrument came in, I could predict what it was going to do from in the future. Okay. And now what was the neat thing for me, and this will be coming out published very, very shortly, I actually noticed something. Data follows people. I know it sounds stupid, it sounds obvious, but what does that mean? I'm going to skip the top part here and get right to the project lifecycle. As a project starts, lives, and dies, the data access patterns do the exact same thing. This is the general modern patterns that we've seen on the formation, running, and dissolution of just about any project at the University of Miami, regardless of the functional areas for it. It actually got to the point where I was able to predict when a project was going to end before anyone told us for this. And a somewhat embarrassing thing, I emailed my boss about a large customer and said, hey, they're running down to these things. Should we go talk to them? And he emailed me back 2 weeks later and said, don't bother. They're relocating. Nobody knew anything. So these patterns are real, and they're lots of fun. So let me tell you what we learned in all this. We went through a long story. What did we actually accomplish through all this stuff right now? The first thing I learned is to actually use the tools that we provide. Okay? How many HPC people out there actually use MATLAB or Studio and use them on their own systems? To use it on your own supercomputer? How did it go when you did it?
Fine.
Was it fine? Because I wasn't when I did mine. Not in the slightest. As a matter of fact, when I went through and I ran these programs, I felt a lot of the pain that I think a lot of PIs feel as well. And so it was a very good learning opportunity for me to actually understand that we had to pay attention and actually use what we're actually producing these days. Metrics, something that's fascinated me for a while. I put out a couple articles on this. No single metric encompasses everything. You can't. And the other lesson I learned from this, and I didn't put it up there because, as I said, it's coming out in publication, CPU hours lie. Anyone who's using core hours or CPU hours to measure the health of your organization or anything other than how your system is being utilized is letting yourself in for a world of hurt. Look at other metrics. Please do. And then finally, internally data-driven. I'm sure we all say we're a data-driven organization, but for the first time, we actually could show our administration that we had the numbers to do this. So I recommend everyone do that. And then finally, does everyone remember when I said earlier on that our patterns were being lost in the noise for all this? This is the most important lesson I learned. The noise is the data. What I thought needed to be filtered out was actually the interactive and random users on my system. And at a certain point, when they were taking up 25% of my system, you got to pay attention to what's actually going on. So that was a very big lesson for me personally to learn on this. So this is really just meant as a broad overview of what we've done. Here's where we are right now for everything. You can see we have our single data access point. I won't go over this. You can take a look at the slide later if you want to. But to show you where we've grown in the last 4 years from there, we're now up to about 10 petabytes of active data, which is fairly reasonable over a 3-4 year time period. But what's more important is with our new way of approaching things from a user perspective, we've actually expanded our community to places we never thought we would. Any questions?
Anthony Carvalhoza, Rockefeller.
CIO of Rockefeller, I might note.
And in case it wasn't obvious, I've worked with Joel in the past quite a bit. So, so you've classified your users into 4 basic categories based on data
groups.
patterns. Was there any value in users? Were there any users who fell outside one of those 4 patterns?
Absolutely.
And was there anything to be learned from people who couldn't be classified?
Yes. The answer to both those questions is yes. We did have users who fell outside of the patterns, and what we discovered, this was more of a temporal thing than it was an actual basis of analysis itself. We noted that when people didn't fall into these patterns, they usually fell back into them after a short period of time for them. But what we learned from it is that nothing is written in stone. We have to look at it all the time, and we have to constantly reevaluate what we're doing to make sure that it is a true ground state.
Just one follow-up. Is there, so I imagine the dean of the school, if hearing about this project, would start to say, Joel, can you give me a little intelligence on when people are winding down here? Maybe they're looking for an offer somewhere else. Ever any temptation to do something like that in terms of behavioral?
Absolutely not. Are you familiar with the prophet Cassandra from Greek mythology? Nobody likes a true prophet. In all seriousness, we've spoken to people about this. And what it actually wound up happening is that instead of looking for projects that may be winding down or research that may not be fulfilling its goal, we actually have been assigned to look at students who are no longer graduating, and we've been given the job to work with enrollment and retainment to actually apply this type of technology and see what we can do. Any other questions? Really?
I have more of a comment than a question. It was interesting for me to see you talk about, maybe the analogy is the highway system. You build a good infrastructure
Absolutely.
to, because there's bottlenecks, and then instantly it fills up to capacity with more users who weren't using it before because suddenly it works really well.
It works, right. Absolutely. And I've been victim of my own success beforehand with this. Like the talk I gave at the sales conference a while ago, we had something similar with this with machine learning. I think the neatest thing we did about this one was we really changed internally organizationally to be more focused around the users. I no longer ask my people, how many programs did you deploy? How many cores are updated or anything like that. Now it's, how are the users doing? Where are they going with all this stuff? So for us, that was a big deal. All right, well, thank you all very much. I appreciate your time today.